This video is going to show a couple of examples of how to solve quadratics by completing the square. In an earlier video, I explained how to solve by completing the square, so I'm going to give 4 examples of doing the work. Number 1, x squared minus 6x equals negative 91. When solving by completing the square, we have to make sure we understand the directions. It does say to solve. That's going to be an x equals. Solving means x equals, which also means we're going to move everything to the right of our equal sign. Solving by completing the square is useful when our a value is equal to 1 and our b value is an even number. This is correct. So we have an a value of 1 and a b value of an even number, so it'll be easy to complete the square. The first step of completing the square is to isolate your constant. Now our constant is negative 91, and as you can see, it is already isolated on the right-hand side of our equal sign. That means that we have all of our x values on the left and our constant on the right, so we can actually skip that first step since it's already isolated. The second step of completing the square is where we do the workbox. The workbox is where we take half of b and square it. So again, I am going to use just half of b here, and whatever this value is, I'm going to put into the set of parentheses because I don't want to square it until I know what my half of b is. Now my b value is negative 6, so I'm going to put negative 6 into here because it's negative 6 over 2. Negative 6 divided by 2 is a negative 3. Negative 3 squared is a positive 9. This value should always be positive because anytime you square a real number, it will give you a positive value. The next step of this is to add that 9 to both sides of the equation. So when I add the 9 to both sides of the equation, I'll have x squared minus 6x plus 9, because I have to move it to the left-hand side of the equation, equals, so I'll have negative 91 plus 9 as well. Negative 91 plus 9 is equal to a negative 82. Next up on the completing the square, we want to be able to factor this trinomial. Completing the square creates a perfect square trinomial, so this one will factor to become parentheses squared. Since it's a perfect square trinomial, we should be able to take the square root of x squared, which is x, the square root of 9, which is 3, and then our middle sign is a negative, so we should put just a negative inside of our parentheses. The value inside your half of b, this set of parentheses right here, should be the exact same value inside of this set of parentheses, inside of our factor. It is, so that means we've done it correctly. This is still equal to negative 82. Now from here is where we would diverge to our 2 different directions. If the directions say to simplify or to convert to vertex form, we would move everything to the left. But since our directions say to solve, we're going to move everything to the right. We're going to get our x value alone. So we want to solve for this one x value. This goes back to solving by square roots, where we're just going to solve for that x. So inside the parentheses I can't touch yet. I have to get rid of the square by square rooting both sides. So I'm going to rewrite this as parentheses x minus 3 parentheses squared equals negative 82. To undo the square root, the square, I have to square root it because it's the inverse. So we end up having x minus 3 equals, because that gets rid of the parentheses as well. Whenever we take the square root of a value, we're going to put a plus or minus because we're taking the square root of the value. Now, if we plug into our calculus the square root of negative 82, we'll get a non-real answer because we cannot take the square root of a negative. This is where it gives us an imaginary number. So instead of writing it as the square root of negative 82, we take this negative and turn this into an imaginary number, which is how we write I. Now we keep our plus or minus where it is. The I comes out of the radical. That negative will come out to become an I directly outside of that square root symbol. Now since the negative has turned into the I, we're just left with that positive 82 inside of our problem. And because it's imaginary, we're actually going to keep our value like this. We're not even going to change it to a decimal value. We're going to keep it with that I square root of 82. Now the only thing left to do is to still solve for x. We still have to move that negative 3 over. So to move that negative 3, we want to add the 3 to the other side. Now, because we have an irrational but also an imaginary number here, we want to keep our real rational number always in the front. So our answer will be x equals, we have a positive 3, our real rational number will be in the front. Then we'll have plus or minus, then we'll put I square root of 82. And this is our answer. Three plus or minus I square root of 82. This next problem we're going to solve by completing the square. We're going to check to see is it a value is equal to 1 or b value is even. So solving by completing the square will be a viable option. The first step in solving by completing the square is to isolate your constant. This time our negative 38 is not isolated. So we have to isolate that first by adding the 38 to both sides. So we'll have x squared plus 14x equals a positive 38. Now we'll go into the next step of this, which is the workbox. Inside the workbox, we take half of b and square it. Our b value is the 14, so we put 14 over 2 squared. 14 over 2 is 7, so I'll put that inside this parenthesis, and then we square it, which is 49. Now we add the 49 to both sides of the equation. So we'll have the x squared plus 14x plus the 49 is equal to, then we have that 38 plus 49. 38 plus 49 is equal to an 87. Now we'll go to factoring this trinomial because we just created a perfect square trinomial. This will factor to parentheses squared. It's a perfect square trinomial because that's what we created. Take the square root of x squared, which is x, square root of 49, which is 7. And our middle term is a positive, so we put plus in the middle. Again, this should be, this set of parentheses, a half of b, should be the exact same number. We should have a positive 7, we have a positive 7. Still equal to 87. The next step is to determine if we're solving or converting. And since our problem says to solve, we want to move everything to the right and get our x completely alone. We want to get x completely alone. By doing that, we need to get rid of the 7 and the square. The 7 is inside the parentheses, so we have to get rid of the square first. So I'll have x plus 7 parentheses squared equals 87. I want to be able to square root both sides. So we'll have x plus 7 equals, because we're taking the square root of something, we have to put the plus or minus, and then the square root of 87. Now the square root of 87 is a decimal, but I don't want to worry about that decimal just yet. I'm going to keep it as a square root of 87, because if I use a decimal right now, it'll be harder to finish solving it. Next up, we want to get the x by itself by subtracting the 7 from both sides, minus the 7 from both sides. So we'll end up with x equals. Now we'll have that negative 7. That real rational number should always come first. Square root of 87 is irrational, so I'm going to keep the negative 7 in front. Negative 7 plus or minus the square root of 87. Now this is an exact answer because we do not have decimals, but I do want to get the decimal values by plugging them into my calculator. So I have that negative 7 plus the square root of 87. We get approximately 2 and 33 hundredths. So x is approximately 2 and 33 hundredths. We'll do the same thing with negative 7 minus the square root of 87. And we get approximately negative 16 and 33 hundredths. So again, these are approximate answers. The x equals negative 7 plus or minus the square root of 87 is an exact number. But for approximations, you can always check your calculator to see if your values are the same. I'll do 2 more examples. Number 3, going to be x squared minus 12x plus 11 equals 0. I'll put number 4 over here. It's going to be x squared minus 4x minus 91 equals 7. So the first step on completing the square is to isolate your constant. So the 11 is our constant right now. We're going to isolate it by moving it to the other side. So we'll have x squared minus 12x equals a negative 11. Next step is the workbox, so we can create a perfect square trinomial. The workbox is half of b and square it. Our b value is negative 12. And again, our a value is 1. Our b value is even, so completing the square is a great option. So we'll take our negative 12. Half of negative 12 is negative 6. When we square negative 6, we get a positive 36. Again, this number should always be positive right here. So we're going to add the 36 to both sides of our equation. We'll end up having x squared minus 12x plus 36 is equal to, now we have to add that negative 11 plus 36, which is actually equal to 25, so we'll have equal to 25. The whole point of this again is to create a perfect square trinomial so that we can factor this nice and cleanly. This will factor down to parentheses squared. The square root of x squared is x. The square root of 36 is 6. We have a minus in the middle, so we put minus 6. Our half of b, negative 6, should be the same inside of this parentheses as well, which is correct. Equals 25. Now we need to square root both sides to get rid of our square. So I'm going to rewrite the problem. X minus 6 parentheses squared equals 25. I will square root both sides so I can get rid of the square. We end up having x minus 6 equals, so if we're taking the square root of a value, this is a value, we're going to put the plus or minus here. And the square root of 25 is rational, so it will give us a 5. Next step is to add the 6 to the other side. When we add the 6 to the other side, we'll end up with x equals, whenever we add something to the other side, we want to keep this plus or minus with the 5. So whatever we move to the other side here, we're just going to put in the front. So 6 plus or minus 5. That means that we'll have 6 plus 5 and 6 minus 5. X equals 6 plus 5. X equals 6 minus 5. So x equals 6 plus 5 is an 11, and 6 minus 5 is equal to 1. So we have the values of 11 and 1. And we can check it back to our original problem. 11 and 1. We're going to go back to the original. So 11 squared minus 12 times, or parentheses 11, close parentheses, plus 11. And when I press enter, it should give us 0. It does. So 11 works. We'll do the 1. So parentheses 1, parentheses squared, minus 12, parentheses 1, close parentheses, plus 11. If I press enter, it should give us 0 again, and it does. So our two answers are 11 and 1, and these are correct. This last example on this video is going to be x squared minus 4x minus 91 equals 7. Now, it is not necessary to get it into standard form to be able to complete the square. Your a value is 1, your b value is an even number, and these are both constants. We want to isolate the constants, so we want to get all the constants on one side. So in this case, we're just actually going to add that 91 to the other side to the 7. So we don't have to move the 7 back over. When we get this, it'll become x squared minus 4x equals, we're going to add the 91 to the 7, so that would be 98. Again, it's not necessary to put it into standard form first. Next up is the workbox. which in the workbox we do half of b and square it. So our b value is that -4. -4, half of -4 is the -2, so that goes into this parentheses. And the -2 squared is a +4. We're going to add that +4 to both sides of the equation. So we have x squared minus 4x plus 4 is equal to, and then we have that 98 plus the 4, which is equal to 102. Perfect square trinomial will factor, parentheses, squared. Square root of x squared is x. Square root of 4 is 2. We have a minus sign in the middle, so it'll be -2. And again, half of b is -2. That's the same thing in here. Equals to 102. Now we're solving, so we want to move everything to the right-hand side by getting the x by itself. So we're going to get rid of the square by square rooting it. I'm going to rewrite this problem of x minus 2 parentheses squared equals 102. I want to square both sides. Square root both sides. So we'll be left with x minus 2 equals. We'll take the plus or minus, because we're taking the square root of a value. And 102 is not a perfect square, so I'm just going to keep it as the square root of 102 for right now until I get all the way finished, and then I can get my decimal values, since it's going to be irrational. We want to add 2 to both sides. If we add 2, we have x equals. We're adding 2, we're going to put our real rational number first, and 2 is rational. We'll put our 2, then we'll have our plus or minus the square root of 102. Now this is actually the exact answer, 2 plus or minus square root of 102, but we can separate them and get our decimal values. So using our calculator, we're going to do 2 plus the square root of 102, get an approximation, which is 12. And so if we look, this 9 makes this 9 go up to a 10, which therefore makes this 0 go up to a 1. So it's really, x is approximately 12 and 1/10. Then we'll do 2 minus the square root of 102. Again, the plus or minus part is what separates them. And we end up getting, so this 9 makes that 9 go up to a 10, which in turn makes this 0 go up to a 1. So the other answer is x is approximately -8 and 1/10. So we can check our answers by plugging it back in. So it will not be an exact answer, but it'll be close. So we have 12 and 1/10 squared minus 4 parentheses 12 and 1/10 and then minus 91. Now I should get equal to close to 7 when I press enter. And it's a little bit over 7, so that is, we rounded it, so that's probably going to be an accurate answer. We'll do the same thing with a -8 and 1/10. -8 and 1/10 squared minus 4 parentheses -8 and 1/10 and then minus 91. So when I press enter, it should be close to 7. And it is, and we actually get the same values here. So then that means that these two decimal values are pretty accurate. We get an exact 7 if we had plugged in 2 plus square root of 102 in for x and 2 minus square root of 102 in for x. These are the examples for solving by completing the square.